Yes, ma'am. Correct. You got it. Good. Olivia, do you have a question on one? The one that's the toughest that I saw was 30, I think. 30 is a pretty good one. 30's a tough one.
Wait, what are those logos for?
We're going to have a little fun with it. Just do the lesson today.
I know both those logos.
Should I?
I'll ask you one. Just don't say them out loud.
The one on the right is a given.
Should I
That one's easy. The left one's pretty easy too.
Whatever it's in, yeah. All right, I'll give you a minute longer to kind of wrap it up here. 30 is tough. 30 is tough. I'll tell you what, on 30, I will give it to you if you could change it to exponential form. Is that fair? Just simply change it to exponential form and see if we could get it out there.
No, it's like the longer version of it. What's up? Exponential 4. I got you. 30.
Oh, it starts with an L, right?
Sorry, Marcus.
Incorrect.
Incorrect? Oh. Start with an L?
What's that?
Starts with an L, right, on the left? Pretty sure.
I think so.
I've flown on it one time.
I think so.
I'll probably not pronounce it right.
Yes. Yes, that one's the toughest one. That's the toughest one.
It's a pretty tough one.
All right, let's do this. Let's check them out. And again, this is on the podcast. More or less, you're going to get some of these on the test, and they're going to be just, I call them quick hitters. They're just quick to kind of help us to go to other problems that we're going to come to later. First off, 25 is 9. By the way, if you have a question on one, stop me, okay? 27 is? 2. Good. 2. 29, we could cancel log base 8 because they're the same. And so x is equal to 10 to the negative first. You could say 10 to the negative first, or you could say 1 over 10. That's the same thing, right? I'll take either. 26 should cancel. What would that equal? X is equal to 1, right? And I think you said x, which was correct. It would just be x is equal to 1 because everything cancels. Good. I'll give that to you because I said yes, too. 28, what does 28 equal? Negative 1, very good. And negative 1 equals x. 30, if I change 30 to exponential form, what would you get? Olivia, do you know? Katie knows. What'd you get, Katie?
3 to the x power equals 4 to the 3rd.
That's exactly right. So if I shot this over, I would get 4 to the 3rd. That remains the same, but the base of the log, which is the little one in the bottom, shoots over and goes, whoop, remember that, to the other side, and equals 3 to the x. Cool? All right, is there a value that you could think of that you could plug in for x? Yeah, me either. I couldn't think of one either. So I would just say leave it as that for right now. I do know how to solve it, but you're just not old enough yet. We'll do that in like next week and even the following week. Okay? Cool. What about this? ln and log. If I don't know what the base is of ln and log, what is the base of what we call the natural ln, the natural log? Hannah? Good. E. And Diego, what is the common log, which is log? What is the base of that? 10. So if I don't know it, or if it doesn't put it there, just know that it's understood. Okay? Cool beans. Questions on that? Okay, before we get to the project, I've got one major concept to hit on, and I would take some notes on this. If nothing else, making sure you're following me on your homework as you do it along with me, okay? Actually, one more thing before I do hit that. If I did like number 18, okay? 18, where x is equal to 1/4, I plug 1/4 in for what? X, right? You all follow me on that? So what I would get is y equals log base 16 of 1/4. Now, can I cancel anything? Yeah, I can't really cancel it. So what do I change it to? Exponential form. Good. So what do I do with 16? Move it to the other side. And what I would get is 16 to the y power equals 1/4. Okay? Good stuff. Now, this involves what we call 1-to-1, right? Does anyone remember what 1-to-1 was?
Ratio.
Same base. Good. Where we try to get 16 to 1/4 to have the same base there. What would be a good base that would be the same on both sides?
4.
Good. Yeah, good, David. What would the left side turn into then?
The left side would turn into. Oh yeah.
You good?
I can't think right now. My bad.
You good? Hannah? 4 squared. Good. Did you say that earlier? I thought you.
No. I was having a brain fart. Like I couldn't process.
Yeah, that's okay. So we have 4 squared to the y is what the left side is, and the right side would turn into what? Devin, did I hear you? Oh, I thought you were saying it. Does anyone know what 1/4 would be? Hannah, come on.
4 to the negative.
4 to the negative first. Good. 4 to the negative first. So then this is 4 to the 2y equals 4 to the negative first. Y'all follow me on this? Kind of the same thing we've been talking about, where we cancel the 4's because it's 1-to-1, and 2y is equal to -1. And what would y be equal to then?
-1/2.
Good. -1/2 would be our answer for y. Did that help? Does that make sense? So we change it to exponential form and then allow it to be 1-to-1 when we solve for some of these, okay? Equals -1/2. All right, let me backtrack. We're going to have a little fun here. Just as a break in the lesson as we go, because it is a Friday, we're going to play the logo challenge. As a kid, it was like my favorite. All right, let's hold off just for a second because we'll give opportunities here. If you see one, just raise your hand and I'll get to you and we'll go from there. So Victoria, go ahead. Give me one of them. Cool. Dove is this one. Very good. And this one, David, it would be what?
Lufthansa, the airline. Lufthansa. How do you? I say
I
Lufthansa.
think that's right. I think that is
I don't know how to
right.
pronounce
Good.
it.
Rookie mistake.
Y'all are out of the game for this one here. Okay, let's go to the second one, unless someone doesn't know it. We're going to go to the one that's right up here in this category, and we'll go, Devin, go ahead. Amazon is true. And what is the one on the bottom right there? Jack, do you know?
Superhero? Wonder Woman? I don't know.
That's exact. I think it's Wonder Woman, right?
No, it could be Whataburger too.
Oh, it is.
It's
Is that Whataburger?
Yeah,
Well,
it's
no,
Whataburger.
what if it's Wonder Woman.
Yeah, but I thought it could
It's
be
Wonder
Whataburger.
Woman.
I thought it was Wonder Woman too.
It's Wonder
I thought it
Woman.
was that too.
Whataburger.
Okay, let's go to the next one here. We'll do these two before we go into the graphing one. Rosemary, do you know? The FedEx one right here. By the way, did you ever know there's an arrow in FedEx? My mind was blown the other day. I was like, there's an arrow in FedEx. I'm sorry, that's really random.
I didn't know.
Does anyone know? Raise your hand on this one. On the right one, that's here. I feel
You
like
said I was out for the
definitely
second
know.
round. You said I was out for the second round. Technically,
Does anyone else know? All right, David.
BBC.
It's BBC. Yes. The BBC. Yeah, good stuff. By the way, if you've never watched their shows are legit, by the way.
No,
Okay.
because, Jake, it took me years to realize that the Chick-fil-A, like the first C, was actually a chicken. I thought it was like a weird smiley face.
I
I'm
thought it was
so
just a
serious.
weird seed.
Like I thought it was like a weird smiling face, and
Yeah.
I was like, "Oh my god, it's a chicken!" And it probably clicked for me. I had to be like 11. I was like, "Whoa!"
No judgment. Hey, I hear you. I hear you. Okay, now as we go, here's the thing. I need you to really dial in on this because this is the topic that's the most difficult on the next test. I'm not saying the test is difficult, but what I find is that this is the most difficult topic. Okay. Now the good news is if you felt pretty good about graphing exponentials, very similar. This is very similar to that. If you struggled with it, this hopefully will help you, and hopefully we can kind of help you along as we navigate this, okay? All right, so the first thing we're going to do, let's look at 39, okay? We'll do like two together. 39. Now, question on 39, what is the transformation? Where's it transformed? Yeah, so it's inside the parentheses, right? Like think of it as up in the exponent, right? So where will it shift in? Up, down, left, or right?
Right.
It's going to go right 3. Very good, Diego. Does that make sense? So we're just going to put a little note here and just say this thing's going to go right 3 right here. Now, what I do, just similar to what we did with the exponential stuff, I am going to drop the transformations and add it later on, okay? So what we've got is y equals log base 4 of x. I'm going to graph this, okay? Now, the bad news is we can't actually graph a log. There's no way for us to really graph it unless we put it in our calculator. So let's say we can't. So what do we change this to? Hannah? Bingo. Yeah, so we're going to change it to exponential form. So what we can do is we can use exponentials to be able to graph this, okay? So when we shoot 4 over, we get 4 to the y power equals x. And that is the equation that we're going to graph, okay? Now, if we're doing this by hand, which is what I'm assuming, I'm going to plug in values into a t-chart. Now, the only problem with this is what is my input now? What am I plugging values into? Nice, Rosemary. Because of the fact that it's 4 to the y power, I'm plugging in values for y and getting out values for x. Good. So instead of plugging in -1, 0, 1, and 2 in for x, this time we're going to, in a log form, since it's the inverse of it, we're going to plug -1, 0, 1, and 2 in for y. Okay? Now, that can be a little confusing. That's the part that people kind of mess up with. Just be careful. Make sure that when I change it to exponential, plug in for y. So what's 4 to the negative first? 1/4. So I'm putting my output in for x. What's 4 to the 0? 1. Good, David. 4 to the first, obviously, we got 4, and then 4 to the second is 16. Okay? Now let me stop for a second. Are there any questions on where I'm at so far? So far, so good? So then we're going to just graph it. So we're going to go 1/4 to the right, down 1. So it's going to go 1/4 and down 1. This next one is going to go 1 to the right and just stay at 0. This one is 4 to the right, up 1. And 16 and 2 is like way out here. So we could put one out there, but we know that it's going to come this way. And then it's going to come, what's it going to do?
Is it a 0 to asymptote?
Nice, yeah, so it's going to come downward. There's an asymptote there. Good, David. Except, okay, so exponential had a horizontal asymptote, right? But remember, logs are inverses. So now logs are going to have what type of asymptote?
Vertical.
Vertical. Good. So I would make a little note of that. Log have vertical asymptotes, and exponential, EXP I'll say, have horizontal asymptotes. Okay? And that right there would be the graph of 4 to the y equals x, or log base 4 of x. Okay? Now we're not done with it, right? What else did we need to do? Yeah, we didn't do the transformation yet, right? So we've got to come in and do right 3 for all of the points that we were given. So I'm going to go to all of these and just go right 3, put one there. Right 3, put one there. Right 3, put one there. And the horizontal that was at 0 gets shifted to what side? It will also get shifted to the right 3. Exactly. So now we're going to have a vertical asymptote at x equals 3. So there we are. Comes back up, and that's it right there. Okay? Does that make sense? So the red one is the regular one, and then when I shift everything to the right 3, that is now the yellow one. Hannah?
For the test, are you gonna want us to use like different things to change what's in it for the graphic?
You don't. If you put both there, I'll give you credit because I can follow that. I know what you're doing. I'm okay with that. Absolutely. What is my domain, by the way? Of the yellow one?
The domain of the yellow one is
3 to 30.
Good. 3 to infinity. Jake, good work. So the domain would be from 3 onward to infinity. Okay? Good stuff. Can we do one more? do one more together. I know some of this can kind of be mundane. We'll do one more. And if you want to get one more rep, you can. If you want to start on your project, I'll give you that freedom to do it. But I think one more would be good. So let's go to this one here. Let's go to number 41, okay? All right, let's do it together. Let's take away all of the transformations, okay? What are the transformations? Someone just throw them out there.
Left 2 and
The +2, now this is not in parentheses, right?
So it goes up.
Up to.
This goes up 2. Good. So we're going to push it up 2. And
And then it's gonna flip because it's negative.
say that again, I'm sorry.
Oh, is that for me, bro? Oh, I thought you were.
No.
Oh,
Go ahead, Dave.
it's negative, so it's gonna like flip.
Yeah, it's going to reflect. And because it's not with x, right? We're going to reflect over the x-axis, okay? If it was the negative was with x, we reflected over the y. But this would reflect over the x, okay? All right, now we're going to take all of the transformations down, right? To get y equals log base 10 of x. Take all of the other stuff out. We'll include it here in a second. All right, so we go here. We don't know how to graph this, so what do we do?
Put it in the cheat chart.
10 to the y equals x. We then do our transformations. At the end, we first plug in for the y. So we got -1, 0, 1, and 2. Plug in -1, we get 1/10. Plug in 0, we get plug in 1, 10, and then 100. Good. Where's my vertical asymptote? Just from this one. 0, right? It's always at 0 until we transform it. So we're going to go right here at 0, and then we're just going to graph it. So 1/10 to the right, down -1. 1, 0, be just a little above, and 10, 1 would be way out here. So this thing's going to go this way and come down. Okay? All right, now here's my recommendation. I said this on the exponential as we wrap this up. First reflect it, then go up 2. Okay? Wherever, do the reflection first, and then push it right, left, up, or down. Okay? So if I reflect over the x-axis, because that negative is out here, we're then going to say it's not going to kind of go out this way. What's going to happen? Okay, so if the negative was here, it would actually go like this. Okay? That would be reflected over the y-axis, right? But reflected over the x-axis just means that it won't look like this. It's going to look like that. So think of it as like there's like a dotted line here, and it's going to be reflected. Those points are reflected downward. So what was here is going to be up here. So this thing's going to go like this, the green one. Okay? Reflected over the x-axis. Is there anyone confused on that? Okay? So then what do? We push it up 2. Good. So my final graph, I'll do it in blue here. Every one of these points are just going to be shifted up 2. This is going to go up 2 here. This is going to go up 2. And then the new one is going to be in blue. Okay? Can you see the 3 of those? I know it's a little weird. Maybe I probably should do it on a different graph if I was going to do that last one. But that would be the final graph that's there. Okay? All right, question. Why did the vertical asymptote not change on this one? I like that. No right or left movement, right? If you have a vertical asymptote and you move it up and down, did that change?
No.
It didn't change left or right. So think of the vertical asymptotes as something that changes with left or right movement, and horizontal asymptotes change with vertical movement. Okay? All right, good stuff. How did that feel today? Feel okay? Here's what I would say. I'm going to allow you to go ahead to the project right now. Right now you have about 20 minutes left. That's perfect. Probably 15 because I told Jake I'd do the hot seat there. If you need one more of the graphing ones and you're like, Coach, I'm struggling on this, before you go to the project, let's talk through one together if you feel like you need one. If you're like, you know what, I just want to do the project, go ahead and get that done as well. Big picture, 3.2 is due Tuesday. Okay, 3.2 due Tuesday at midnight. The project is due by Monday at midnight. So as you're planning for that, do some of it this weekend. That way you don't have all of this stuff
Okay,
due
what if we're
Monday.
still at school at Monday at midnight? Is it just, can we get it into as soon as possible?
When is the play is next weekend, right?
No, but like realistically, let's just say I'm at school until midnight. Realistically.
It's happened before.
Can you just communicate with me
Yeah,
on
yeah.
that?
What do you
Cool.
think?
Yeah.
We'll
So-
probably be leaving school at 10 o'clock. We'll be good.
I will say this. I recognize there's crazy stuff going on. So just let me know.
Got it.
You know, let me know. We can.
Yeah, no, she pencil.
Actually, if we go to midnight, I would not be surprised.
We did it last year.
That was the worst night of my life.
Thursday night.
Yeah.
Hi, Jack. Good knowing you.
Did you get this here?
Yeah.
I didn't
Yeah,
catch you
who's this
eventually.
I don't know why. He explains grass. I tend to get
Yeah.
like better than like the last couple years.
I always do I think the part of it is transformations. I wait till later. If you understand the transformations, it helps.
Coach
You
J.
know, because then I mean this part I don't. This part right here is not bad.
Yeah.
And then once I graph it, I then just do the transformations off of it. That always helps me. I don't know.
So what's the difference when I'm solving for the deferred?
Yeah, good question.
Yeah, I heard everybody.
Let me get a new.
Non-deferred is when you pull it out. Deferred is when you wait to the end of the
Yeah.
but I don't get it when it goes out.
What percent? What number is that?
Talk about like what number on the sheet?
Yeah, what number on the sheet?
2. The
2. Okay. Hey y'all. By the way, number 2. If you need some help on this, it's gonna be podcasted here, but I'm just talking through it with Jake with deferred, not deferred. If you need another explanation, I can help you, but you don't have to. Off the project we're talking. Okay, off the project. So deferred was one option, and then there was not deferred, right?
correct.
Not deferred means it is built in the equation. Built into the equation. Okay? So think about it this way. If I have A is equal to, and I think it was compounded
Annually.
annually, right? So we have R over N to the NT power, where P is some sort of value. The big part of this with the not deferred that changes stems from the R. Okay? So like if R is the percentage that I'm getting, right? So what is that percentage there?
The says the account pays 8% compounded annually. It says
Gotcha.
that income tax on the earned interest is 30%.
Gotcha. So the 30% of the 8% goes to the government, whereas 70% of the 8% comes to me. This is me here.
So now you gotta do 0.7 times 0.08.
Good. And
This is 0.56.
good. 0.56. Good. So now the rate is not 8% anymore. It's now the new percentage. And when I plug it into R, whatever I get out for A is going to be my answer. That's called not deferred. Meaning it's as I go. Every time it compounds, it's going to take the 0.056, and because I get the full amount because the government is getting the other 2.4%
Okay.
or whatever. Okay? So that would be that one. That would be not deferred. Deferred is different. To give you a kind of a basic example, when I plug in the compounded annually up here, the R still stays as 8%. Okay? Nothing changes there. But let's say I put in $1,000. I know it's different on yours, but let's say I put in 1,000 and I get out 1,500. Okay? So A was equal to 1,500. The part that's getting taxed is what part?
The 1,800.
Well, this would be my total that I would take out after a certain
the
period of
500.
time. The 500. Good. So 500 is my interest. And of the 500, 30% goes to the government and 70% goes to me. So what I do is I could take 70% of 500, which is like 350. That's the amount of money I get, and then I add that back into the 1,000 that I put into it initially.
Traigo when he comes back.
Yeah, absolutely. Hannah? Does that help you there?
Yes.
Could I help you? Do you have your Desmos on your, well, you could pull it up on your Mac, right? Hey, I don't know if I told you all this yesterday. It might have been, there was one group that I did and others that I didn't. If you go to Desmos like this, it's kind of nice. I'm going to delete this one. Some of you put in equations like this here. 1,000, which is what I put in, e to the 0.06x. Do you know Desmos, you can actually put in, like in for x, I could put in, let's say 25 years. So what I'll do is I'll put in 25, and it actually gives me what that would be. And then I could delete the 25 and put 50 in, and it gives me how much I would have after 50, and then plug in 75, and so on and so forth. Kind of cool. So it can do that for you. Hannah, that might be faster than what you're doing. I will also, though, tell you that I think when you... That's okay. You could still put it in as the long one there and still do that. May I real quick show you this? So when you do this, when you go to second entry, notice that there's 2 parentheses here. There needs to be 2 on the other side. So when you do that, that will give it to you. Cool? Just so you know how to do it on there.
Gotcha.
Yeah, there's really not an explanation. It's really the flow of comparing the 3 and the years. That's excellent. Yeah, that's perfect. The only question I had is, okay, so this is all one equation. You're good to go? You good, Victoria?
Yeah, I'm good. I'm trying to figure out which paper or project I'm on.